Have you ever wondered how a company takes this just absolute mess of daily data and somehow turns it into those clean, sharp insights that actually drive decisions? Well, that whole process, that hidden magic, that's data engineering. It's the invisible engine that powers modern business, and we're going to break down exactly how it works.
So let's start with a really simple question. Why can't a store just hook up its analytics directly to the checkout register? I mean, all the data is right there, right? But the answer to this question gets to the absolute core of why data engineering even exists. It turns out the systems that run a business day to day are completely different from the systems you need to analyze that business.
You have to think of it as two totally separate worlds of data. In one world, you've got your operational systems. These are the things that handle the daily grind, like that point of sale system in a store. But in the other world, you have analytical systems, which are built for one thing and one thing only, finding insights and making reports. They are built for completely different jobs. And this table really lays it all out. On the left, you've got OLTP, your operational systems. They're built for thousands of tiny, super fast transactions, like adding an item to a cart. On the right, you've got OLAP, analytical systems. They are designed for huge, complex questions that have to scan through years and years of data. If you tried to ask your live checkout system, hey, what was our best-selling product for the last 3 holiday seasons, you would literally grind the entire thing to a halt. So what's the solution? You need a separate place, a dedicated arena for all of that heavy-duty analysis. And that place is called the data warehouse. Think of it as a specialized library. It's a central copy of all your important historical data, but it's structured specifically for asking those big, tough questions without ever slowing down the daily business. Okay, so we're going to build this data warehouse. But you can't just start dumping data into it willy-nilly. Just like if you're building a house, you need a blueprint first, right? Well, in the data world, that blueprint is called a data model. And this quote just hits the nail on the head. Data modeling is how you plan everything out. The organization, the structure, how all the pieces of data relate to each other. It's the step that makes sure everything is consistent and actually makes sense. You know, if you get this blueprint wrong, the whole house is going to be a mess from the start. So, what does this blueprint usually look like? Well, for most data warehouses, the absolute gold standard, the design that everyone uses, is called the star schema. And there's a good reason it's so popular. It is simple, it's powerful, and it is incredibly efficient for the exact kind of analyses that businesses need to do. And yeah, it's called a star schema because it literally looks like a star. Right in the middle, you have a big table called the fact table. This is where all the numbers live, the core measurements like sales amount or how many items were sold. Then, connected to it like the points of a star, you have what are called dimension tables. These give you all the context, the who, what, when, and where. This really clarifies their different jobs. The fact table tells you what happened in numbers, while the dimension tables tell you all the juicy details about what happened in words. I mean, a fact like $100 is pretty useless on its own, right? But it becomes powerful when the dimensions tell you it was Jane Doe who bought a laptop on a Tuesday from the downtown store. That's the magic. Okay, so we've got our blueprint, the star schema. Now let's zoom in on the core principles that really define the data warehouse itself. What actually makes it so different from just any old database? I absolutely love this definition from Ralph Kimball, who's basically one of the godfathers of data warehousing. It's just so perfect. The two key parts are, 1, it's a copy of transaction data, meaning we don't ever mess with the live systems, and 2, it's specifically structured for query and analysis, which points right back to that star schema blueprint we just talked about. Another pioneer, Bill Inman, laid out these 4 key characteristics. First, it's subject-oriented. It's organized around business ideas like sales or customers, not weird technical tables. Second, it's integrated. It pulls data from all over the company and forces it to be consistent. Third, it's time variant. This is huge. It keeps years of history so you can spot trends. You can't predict the future if you don't have a good record of the past. And finally, it's non-volatile. Data goes in, but it almost never comes out. It's a stable, unchangeable record of what happened. So, we have the design. And we have the principles. But how does all that raw, messy data from all over the place actually make its way into our beautiful, clean data warehouse? Well, for that, you need a data assembly line. The classic process for this assembly line is called ETL. It stands for extract, transform, and load. First, you extract the data from all its different sources. Then, and this is the most important step, you transform it. This is the cleanup phase. You fix inconsistencies, you standardize everything, and you reshape it into that star schema we designed. Finally, you load that clean, ready-to-go data into the data warehouse. But there's a modern twist on this. With today's super powerful cloud data warehouses, a new pattern has shown up, ELT. Instead of transforming the data before you load it, you extract it. You load the raw stuff directly into the warehouse, and then you transform it, using the warehouse's own incredible processing power. It's a bit more flexible, and honestly, it's quickly becoming the new normal. So far, we've been talking about, normal-sized data. But what happens when the scale just gets insane? When we cross over into the world of big data, our little assembly line needs some serious rocket boosters. So what does big data even mean? Well, people usually talk about the 3 V's. First is volume. We're talking about petabytes of data, so much that no single computer could ever hope to handle it. Then there's velocity. The data is just flooding in at incredible speeds. Think social media feeds or millions of sensors. And finally, variety. It's not just neat rows and columns anymore. We're talking messy text, images, videos, you name it. Your traditional tools, they can't keep up with the 3 V's. It's impossible. To tame big data, we need totally different kinds of systems, distributed engines that can spread out the work across hundreds or even thousands of computers all at once. The early big data tools were pretty slow because they were constantly having to write information down to a hard drive between steps. But the modern engines, like Apache Spark, are a game changer. They do all their processing in memory, in RAM, which can make them up to 100 times faster. That in-memory speed is really the key to handling today's massive data streams. All right, let's bring it all home. We've gone from messy, raw data to designing a blueprint to building a warehouse and creating this powerful pipeline to fill it. So what's the big payoff? Why do we do all this work? At the end of the day, the single most valuable thing that data engineering creates is a single source of truth. It's one central, clean, and trusted place where everybody in the entire organization can go to get consistent answers. No more arguing over whose spreadsheet is right. This is the official story. And that single source of truth becomes the foundation for everything that matters. It's what powers those BI dashboards the executives look at every morning. It's where the numbers for all the official financial reports come from. It's what analysts use to figure out what customers actually want. And maybe most importantly today, this is the high-quality fuel that you need to train powerful AI and machine learning models. Without this clean data, AI is just guessing. So, data engineering is this incredible hidden factory that takes worthless raw material and turns it into pure insight. The real magic isn't just in the machinery, but in what it empowers us to do. So I'll leave you with this. Now that you've seen inside the factory, what powerful questions would you ask of the data it creates?